Example 6. We want to evaluate the following nasty-looking integral. First of all, it's a definite integral. The boundaries are 0, and then the upper boundary is 3 square root of 3 over 2. So that's kind of give you a glimpse of the nastiness of this problem. The integrand, x cubed on top, the bottom we have 4x squared plus 9, all of it raised to the power of 3 halves dx. So you can see that this is not your everyday integral. And now we need to solve it. The main difference between working with definite integrals and indefinite integrals is the fact that every time you do a substitution, you want to adjust the boundaries. So otherwise, you solve, and at the end you need to go ahead and fall back and resubstitute back if you want to use the original boundaries. In this case, as it turned out, we're going to have 3 substitutions. Okay, so instead of finding the solution in terms of the last substitution and then go back and replace everything, we want to adjust the boundaries as we go. It's easier this way. So let's see. The main thing is this. If I'm looking at the denominator, it doesn't look like one of the 3 forms of trigonometric substitution. Remember, this doesn't look like either square root of ax squared minus x squared, or the square root of x squared minus x squared, or the square root of a squared plus x squared. So, the fact that the exponent is 3 over 2 gives us a square root, right? But we need to do something with the 4x squared plus 9. So the first task is to convert or to rewrite the denominator so it will look like one of the 3 forms of trig substitution. To do so, I'm going to let u equal 2x. Okay? And the reason is now I have u squared plus 3 squared, u squared plus 9. So that conforms with one form of trig substitution. Now let's see what happens if I do this substitution. Dx is du, so that by itself is not a problem. I'm sorry, dx is 2dx. So we need to have dx, so dx should be du over 2. What about x? I need x as well. If u equals 2x, then x equals u over 2. Because I'm going to need x cubed and I'm going to need a dx. So I took care of this, and the next thing I need to take care of the boundaries. Okay, when x equals 0, then u equals 0, not a problem over there. When x equals 3, square root of 3 over 2, then u equals 2x is simply going to be twice as much, or u becomes 3 square root of 3. Okay? So now I'm ready to change the integral. So let's say I, our original integral, I'm going to rewrite it one time here. 0 to 3 square root of 3 over 3 x cubed, I'll write the x right here on top, over 4x squared plus 9 to the 3 halves. Going to look like the integral from 0 to 3 square root of 3. And I have u over 2 cubed for x cubed. And for dx, I'll have du over 2, like so. And the denominator will be, instead of 3 halves, I'll write the square root. Instead of 4x squared, I have u squared plus 9, or I can write it as 3 squared if you want, and then cube the whole thing.
On the left integral, you have like 3 square root of 3 over 3. Do you mean that to be 3 square root of 3 over 2?
This is over 2, I'm sorry. Thank you. So, next, let's simplify this a little bit. Okay, look here, we have 2 cubed is 8, times 2 is 16. So we're going to factor 1 over 16. Okay, and the integral is still going to be 3 squared root of 3. And we end up u cubed du on top. And at the bottom we'll have the square root of u squared plus 3 squared, all of it cubed. So this was the first substitution. Now I have u squared plus 3 squared, or x squared plus 3 squared, for the form of x squared plus 3 squared, and the substitution is what? The tangent. So now we'll substitute, we'll say u equal, but we have 3, so u equal 3 tangent theta, and therefore du will be 3, and the derivative of the tangent is secant squared. So we'll have du equal to 3 secant squared d theta. What about the denominator? Well, the denominator, u squared plus 3 squared, now will be substituted by 3 or 9 tangent squared theta plus 9, like so. Factor out the 9 and take its square root, and you have 3 outside, and here you have tangent squared plus 1. But tangent squared plus 1 equals the secant squared, right? So we end up having 3 secant theta in the denominator. So if you cube it, so let's cube everything now, like so. And you'll end up having 27 secant cube. So this is our denominator. So what else I need to do? Boundaries. Okay, so the boundaries. Again, let's look at when theta equal, u equals 0. Since u equals 3 tangent theta, we want 3 tangent theta to equal 0. Again, the domain of the tangent, we're talking about negative pi over 2 to pi over 2. So on this domain, it happened only theta equals 0, going to give you this result. Okay, when u equals 3 square root of 3, right, it means that we want 3 tangent theta to equal 3 square root of 3, or tangent theta to equal square root of 3, or theta equals what? Again, on the domain negative pi over 2 to pi over 2, tangent of 60 degrees or tangent of pi over 3 equals square root of 3. So theta is pi over 3. So the new boundaries will be 0 to pi over 3. And now we are ready to rewrite the integral I, right? So I will be 1 over 16. The numerator will be u cubed. Well, u cubed is 3 tangent theta cube, or 27 tangent cube theta. Du is 3 secant squared theta, d theta, like so. And the denominator is 27 secant cube theta. And the boundaries from 0 to pi over 3. Okay, 27 and 27 are being reduced. Secant squared and secant cube will give us secant in the denominator. We have 3, so we'll factor out the 3. We have 3 over 16 as the constant that multiply the integral. from 0 to pi over 3, and what survives in the numerator is tangent cube of theta, and what survives in the denominator is secant theta, d theta. Now, this is much nicer than where we started, but we are not out of the woods yet, because I don't see a clear tangent-secant combination to solve this at this point. You can play with it a little bit, but you'll realize after a while that, you know what, it's not working. So if all else fail, go ahead and write everything in terms of sine and cosine. This is a good advice that we were given when we studied trig, and it applies here as well. So the integral in terms of sine and cosine will be 3 over 16 with boundaries 0 and pi over 3. The tangent is sine cube over, tangent cube is sine cube over cosine cube. Okay? The secant in the denominator is 1 over the cosine, so we end up having cosine in the numerator, like so. And now we're going to end up having 3 over 16, 0 to pi over 3, and we reduce, and we'll have sine squared of theta, d theta, and here we have sine cube divided by cosine squared. Okay, this is not clear enough, but now it's clear. And now, if you think about it, you have odd power of the sine. Remember, that will be case B when we did trigonometric technique. Case A was odd power of the cosine, case B was odd power of the sine, and the idea here is to factor sine cube, so we'll have sine squared, and then we'll have sine theta d theta. And sine theta d theta, the antiderivative of sine theta d theta is the cosine. So it's a convenient differential. So we'll write sine squared of theta times sine theta d theta divided by the cosine squared. Since sine theta is the sine theta d theta, or negative sine theta d theta, is the cosine, right? We can have another substitution here, and we'll have W equal, actually, I'm sorry, I jumped the gun here. One more substitution, we're going to write sine squared as 1 minus cosine squared. And then we'll do the third and final substitution. So, 3 over 16, the integral 0 to pi over 2 of 1 minus cosine squared theta and times sine theta d theta divided by cosine squared. Pi over 3. It's been pi over 3 all along. Okay. Sorry. So now we let W equal cosine theta, and dW will be negative sine theta d theta. Okay? And now we have the boundaries. The boundaries. When theta equals 0, W equal cosine theta equal 1, right? When theta equals pi over 3, then W equal cosine pi over 3, well, that will be 1/2. So the new boundaries will be 1 to 1/2. And in the last form, the final substitution give us 3 over 16 integral instead of theta equals 0, we have w equals 1. Instead of theta equal pi over 3, we have w equals 1/2. And here we have 1 minus w squared over w squared. And here we have negative. Since we have negative sine theta d theta, then we have negative dw, like so. In order to just get rid of the negative, I'll write w squared minus 1. So we're looking at 3 over 16 integral from 1 to 1/2 w squared minus 1 over w squared dw. Break it down into w squared over w is 1, 1 minus 1 over w squared dw, and now evaluate the antiderivative. Okay? So, this is pretty much the end of the road. The antiderivative of 1 is w. The antiderivative of negative 1 over w squared is positive 1 over w. And we need to evaluate it from 1 to 1/2. So let's see what is the answer here. 3 over 16. For 1/2, we have 1/2 plus 2 minus for 1, we'll have 1 plus 1. So this will be 5/2, right? Minus 2. Five half minus 2, so it's 1/2. So we end up 3 over 32. Wow. No problem.